Hello student, once again welcome you all. Today we are going to discuss about the differentiation, basic of differentiation, and we just start from the beginning. What is the definition of differentiation and the meaning of rate of change? What is the rate of change? And from that we just construct the definition of differentiation, and then after that the formulas associated with the definition and the derivative of some standard functions. Okay, so these three things today we are going to discuss. Let us start the differentiation. Okay, so the first is, what is the meaning of rate of change? What is the meaning of rate of change? Suppose if we have the particle or body. Okay, suppose if we have a body and it is start from the point A and it will reach at the point B after some time. Suppose this is your point B, this is the destination. Okay, that body has to be there after some time. Okay, so let us consider that after some time t, body covers the distance is equal to A. Okay, and so this is nothing but actually displacement of the body from origin O to A. Sorry, from the point A to this point. Suppose this is C. Okay, and this is called as a displacement of the body, and this displacement is depend on what? Displacement is depend on your t, time. Okay, so we know that what is by velocity? Velocity is nothing but what? Change in displacement with respect to time, means distance upon time. Am I right? I think in physics you have seen all these things. Okay, so distance upon time is nothing but velocity, and it is also called as what? V is equal to rate of change of displacement with respect to time. Here this S is what? S is dependent. This is dependent and T is independent. Okay, S is dependent means what? S is depend on T. Suppose the train is at the station. Okay, so as time goes, it will change its position, its velocity, its speed will goes change. Okay, and after some time it will reach to of another destination, isn't it? So therefore as time goes there is a increase in the speed also, or there is a change in the displacement also. Okay, and it leads to the acceleration also. So therefore we know that acceleration is nothing but change in velocity with respect to time. This is nothing but rate of change of velocity with respect to time. This is nothing but rate of change of displacement with respect to time. Okay, and our idea is also come from here. Okay, suppose if we have the function y is equal to fx. Now y is dependent here and this x is independent here. The value of y is depend on x. Okay, so value of y is depend on x, therefore y is dependent and it is depend on the x. Therefore if the term dy by dx is there, if the term dy by dx is there, we call it as derivative of y with respect to x, or rate of change of y with respect to x, or rate of change of dependent variable with respect to independent variable. This is the basic idea about that. Rate of change, the meaning of rate of change, isn't it? Now we will going to see what is the definition of derivative. Okay, so let us see the definition of derivative. If fx is a given function on an open interval, then the derivative of fx with respect to x by the method of first principle is given by f dash of x is equal to limit fx plus h minus fx upon s as h tends to 0, and this is also called as dy by dx. F dash of x is nothing but dy by dx, or it is also called as y dash, or it is also in some books you will find y1. Okay, the meaning of y dash, y1, dy by dx, f dash of x is same. Here your function is y is equal to fx. This is your function. Y is equal to fx is the function, and if you want the derivative of that y with respect to x, then this is the definition. With the help of this definition, whatever the function you have, you can find the derivative of that function if you know the basic principle. Not even standard functions, you can also differentiate any function with respect to x, or in with respect to any variable, whatever that. isn't it? Okay, suppose if you want the derivative of function at particular point, then what? Okay, we just have to replace x, this x by a. Suppose if we want the derivative of y is equal to fx with respect to x at x is equal to a. Suppose we want the derivative at x is equal to a. By method of first principle, we just have to replace this x by a. See, I have replaced this x by a here. Also, I have replaced this x by a here. This is called as f dash of a. This x again replaced by a here. F dash of a is equal to limit h tends to 0. Everybody knows about the limit. Okay, if this limit is exists, then and then derivatives exist. Okay, obviously, if the function is differentiable, we can find out the derivative of that function. Okay, now at the particular point, with the help of this definition, we can also find the derivative of the function. So, derivative of the function at the given point, and this is the basic definition of derivative. See, there is a lot of calculation for this definition also. We are not going in detail about that. Okay, we are here to only discuss about the basic. Okay, and that is useful for us. There is a huge definition. There is a very long lengthy calculation is there. We just take small increments in x and y, delta x, delta y, and then we are uh, taking limit as delta x tends to 0 and so on. Okay, so we are not going in detail about that. We just see the definition and we are using this definition to find the derivative of some standard function. Let us see the one example and then we just uh, take assume all that definition is also valid for all the derivative of the standard functions. Okay, so let us see one example here. Find the derivative of x raised to n. Now here y is equal to x raised to n, or consider here, so let fx is equal to what? X raised to n. What is your f of x plus h? Your f of x plus h should be what? Replace x by x plus h raised to n. Isn't it? Now use the definition. What is the definition? So your definition is like this. See, therefore by first principle of derivative, what we have? Dy by dx or f dash of x. This is equal to limit f of x plus h minus fx upon h as h tends to 0. Isn't it? So replace the value of x plus h and fx. This is equal to limit. What is f of x plus h? F of x plus h nothing but x plus h raised to n. Okay, so this is x plus h raised to n, x plus h raised to n minus fx is nothing but x plus x raised to n divided by h is there as h tends to 0. Got it? Okay, so this is equal to, now call it as 1. We have to expand this. We know the binomial expansion here because the expansion of this is, we know the expansion of a plus b bracket square. What is the expansion of a plus b bracket square? This is a square plus twice ab plus b square. Everybody knows this. Okay, what is the expansion of a plus b bracket cube? This is a cube plus 3a square b plus 3ab square plus b cube. Am I right? But what about a plus b raised to 4? What about a plus b raised to 5? What about a plus b raised to n? In general, what is a plus b raised to n? And we get with the help of binomial expansion. This is binomial expansion. And we just expand this. And what is the binomial expansion? See, a plus b raised to n is given by nc0. Okay, a raised to n, b raised to 0. B raised to 0 means 1. Okay, then nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2 plus up to so on plus ncn a raised to 0 b raised to n. If you observe, you can see that the power of a is goes decreasing, power of a goes decreasing and power of b is increasing here. See, in the first step power of a is n, in the second step power of a is n minus 1, n minus 2, and in the last term the power of a is 0. And what about power of b? The power of b is 0 in the first, second power of b is 1, third power of b is 2, and so on. In the last power of b is n. And what is NCR? NCR nothing but what? Your NCR is nothing but combination n factorial divided by r factorial into n minus r factorial. From this, we will get that NC0 is equal to 1. NC1. What is NC1? NC1 is equal to N. NCN is equal to 1, like this. So on. You will get in this way. Okay, we just use this expansion. So what is the expansion of x plus h raised to n then? Therefore, from 1. What is x plus h raised to n? See, x plus h raised to n is nothing but nc0 x raised to n. H raised to 0 is 1 plus nc1. Okay, this is nc1 x raised to n minus 1 into h raised to 1 is there, power of h is increasing now, plus nc2 x raised to n minus 2 h raised to 2 plus so on, plus up to ncn, then x raised to 0 means, and I'm not writing that because x raised to 0 is 1, and simply it is h raised to n. You understand this? Okay, I am using this expansion here. And what is the value of this? This is nothing but nc0 is nothing but 1. The value of this is 1. See here, 1. And what is the value of ncn? This is again 1. nc1 is nothing but n. Replace all these values. So then it is nothing but x raised to n. nc1 is nothing but n. X raised to n minus 1 into h plus nc2 keep as it is, x raised to n minus 2. That term will get automatically 0 after that. That's why we are not finding nc2 here. H square is there, plus so on, plus up to, plus ncn is nothing but 1. H raised to n is there. Okay, so replace this value in equation number 1. So therefore equation 1 becomes, so dy by dx is equal to, dy by dx means d dx of x raised to n. Y is nothing but x raised to n. Okay, so this y is nothing but x raised to n. Remember this. This is equal to, put the value of x plus h raised to n. This is the x plus h raised to n, this value. Okay, so this is x raised to n plus n x raised to n minus 1 into h plus nc2 x raised to n minus 2 into h square plus up to h square, and this is minus x raised to n as it is. See here, that term I have written as it is, x raised to n. See here in the equation number 1, I have written the expansion for this, and I just keep this x raised to n as it is. This is the x raised to n. That x raised to n is here. H is there. H as limit h tends to 0. This is your dy by dx. Okay. So therefore, see, if you observe, this plus x raised to n minus x raised to n get cancelled. Okay, and in every term there is h. See here, h is there, h square up to h raised to n. This is h raised to n. Okay, this is h raised to n. In every term there is h. Therefore, I just take that h common so that I can cancel it with the denominator. Okay, so therefore dy by dx is equal to, h is outside, or first write down the limit h is there outside, and inside the bracket we'll get n x raised to n minus 1. This is the first term. Then after that nc2 x raised to n minus 2 into h is there, plus up to h raised to n minus 1 divided by h as h tends to 0. See, if you observe, h square is here, okay, and only h is remaining. One h I just take common, and from every term I just take h common, okay, and cancel it with the denominator. What is remaining? So therefore dy by dx is equal to dy by and if we apply the limit as h tends to 0, what happens? So if we take h, there is no h in this term, keep as it is. This is equal to n x raised to n minus 1. This term is as it is. Now what happened with this second term? H is 0. If we take h is 0 here, this term becomes 0 plus 0 plus 0. And from that, every term becomes 0 because h is there, and if we are applying the limit as h tends to 0. So what is the only remaining? N x raised to n minus 1. And therefore, d dx of x raised to n is equal to what? N x raised to n minus 1. This is the formula. This is the derivative of x raised to n. So you can find out the derivative of any power of x with the help of this formula. Suppose if you want d dx of x raised to 10, what is the answer? N is nothing but 10. 10x raised to 10 minus 1. This is equal to 10x raised to 9. Got it? So in this way, whatever the power of x, you can find out the value. That power should be natural number. Okay, if it is negative, then no problem, you can use this formula also. Okay, here this formula is for n natural, n belongs to n, but you can use that formula also for integers. You can also use that formula if your n is rational number, isn't it? Okay, so hope you understand this. In this way, you can find out all the formulas with the help of first principle of derivative. Okay, you just have the function, find out fx, find out f of x plus h, replace all that values in the first principle of derivative. This is the first principle of derivative, and just calculate them. You will definitely get the answer. Okay, and we just have all these results. Derivative of trigonometric function. See, from the first principle, you will get derivative of sin x is equal to cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. Derivative of sec x into tan x. Derivative of cosec x is minus cosec x into cot x. Okay, if you have the logarithmic function, also you can find out the derivative of logarithmic function with the help of first principle of derivative. Okay, so if you have a function log x, then the derivative of log x is 1 upon x. Derivative of e raised to x is e raised to x. There the derivative, see here, e raised to x, derivative of e raised to x is as it is, e raised to x. It will not change the function as it is. Okay, derivative of a raised to x is a raised to x into log a. This is also very simple. Okay, if you have the algebraic functions, for a constant function, derivative of 0, understand, this is for the constant function. If the function is constant, then the derivative of that function should be 0. Okay, if x raised to n is there, its derivative is n x raised to n minus 1. We have seen this. Okay, 1 upon x raised to n is there. Then take this x raised to n into the numerator, it become minus n, and use the same result. You will get this answer, minus n upon x raised to n plus 1. Okay, derivative of root x is 1 upon 2 root x. In this way, these are all standard functions. Basic formulas you should have to remember, or at least all these formulas, so that you can find out the answers of some basic examples. Okay, without this you cannot find the answer, isn't it? Okay, so let us see some examples with the help of this. Find the derivative of following from the definition. From the definition, you can also find out the derivative of all this. Okay, or otherwise, you can also find out the derivative of these all functions with the help of directly formulas that we have seen earlier. Okay, so see, root x. What is the derivative of root x? So, first function, the answer of first. Fx is what? Fx is equal to your root of x, root over x. What is x? F of x plus h? Your x plus h is nothing but root over x plus h. Am I right? And now use the first principle. What is the first principle of derivative? So therefore, by first principle of derivative, what I get? So this is equal to what? Dy by dx. This is equal to limit f of x plus h minus fx upon h as h tends to 0. Replace the values. F of x plus h nothing but your, so this is equal to limit as it is root over x plus h minus root over x divided by h as h tends to 0. Now to solve this type of limits, we should have to rationalize the numerator. You know about the rationalization. So this is equal to what? This is equal to limit root over x plus h minus root x divided by h into Divide and multiply by rational of this numerator. Root of x plus h plus root of x divided by root of x plus h plus root x. Got it? Okay. So solve this as x tends to what? H tends to 0. What is there in the numerator? So in the numerator we will get this is a plus a minus b, a plus b. So this is what in the first bracket root over x plus h minus in the second bracket root x, and then root of x plus h plus root x divided by what? Divided by x plus h in the root plus root x. This term as it is and this h is also as it is. This is h as h tends to 0. Okay. Now what happened? See, root of x plus h. This is a minus b, a plus b. And what is the formula for a minus b, a plus b? A minus b into a plus b is equal to a square minus b square. We know this formula. I just use here. A is nothing but a plus h and b is nothing but root x. Okay. And this is equal to what? This is equal to limit root over x plus h bracket square a square minus b square divided by h as it is root over x plus h plus root x as h tends to 0. Now root get cancelled in bracket raised to 2 is there. So this is equal to what? Limit of x plus h is there only minus x is there only divided by h into root of x plus h plus root x as h tends to 0. Got it? Okay. So this is equal to what? This is equal to now this plus x and minus x get cancelled. Only h is there, and that remaining h also will get cancelled with this h. Okay, and if we apply the limit as h tends to 0, what is the remaining? So dy by dx is equal to what? 1 upon h is equal to 0. Root over x plus 0 plus root over x. What is remaining? So therefore dy by dx is equal to 1 upon root x plus root x. What is root x plus root x? 2 root x. Therefore d dx of root over x is equal to 1 upon 2 root of x. Understand? So in this way we can find out the formula with the help of basic definition of derivative. See, in the previous page we have seen the derivative of root x, where it is, see, this is derivative of root x is nothing but 1 upon 2 root x, isn't it? And that same we have now with the help of basic principle also. In this way you can also find out the derivative of all these functions with the help of basic definition of derivative. Okay, now what is the derivative of cos second? D dx of, this is cos of 3x plus 2. Now what is the cos of derivative of cos? D dx of cos. D dx of cos x is nothing but minus sin x. We know that. And this is equal to what? Minus sine of 3x plus 2. We can also find out with the help of definition also. No problem. Okay. So minus sine of 3x plus 2. Again take the derivative of 3x plus 2 and it is nothing but into 3. This is minus 3 sine of 3x plus 2. Isn't it? Okay. So this is the derivative of that. We can see, we can find out this derivative with the help of that formulas. That in the on the previous page we have seen all that formulas. And what about the derivative of this 3x plus 2? This is the part of composite function that we will discuss in the next lecture also. Okay, but you can also find out the derivative of 3 cos of 3x plus 2 with the help of definition, isn't it? Okay, now what about this 4 raised to x? What is the derivative of d dx of 4 raised to x is equal to what? We have the formula derivative of d dx of a raised to x. What is that derivative of a raised to x? It is a raised to x into log a. Now your a is nothing but 4 here. That's why this the derivative of this is nothing but what? Derivative of this is nothing but 4 raised to x into log of 4. That's it. This is the derivative of 4 raised to x into 4 raised to x. Isn't it? Okay. So in this way we can find out the derivatives with the help of definition as well as with the help of formulas that we have seen. What is the derivative of log of 3x plus 2? Okay, what is the derivative? We know that derivative of log x, d dx of log x is nothing but what? 1 upon x. Derivative of log x is 1 upon x. Therefore, this is nothing but what? 1 upon 3x minus 2. Again, take the derivative of 3x minus 2 and it is nothing but 3. Therefore, it is 3 upon 3x minus 2 in this way. Okay, so with the help of definition also you can find out all these for all you can solve all these in this video we have seen what is in by basic definition of derivative, what is the meaning of rate of change, and with the help of that we have seen how to find the derivative of some standard functions. We have seen the differentiation derivative of some standard functions. Formulas are there for trigonometric functions, for algebraic function, and for logarithmic functions, and some examples also we have seen. Here in the next lecture we will discuss about the rules of differentiation. What are the rules of differentiation and how we are using that all the rules to find the derivative of the functions. Okay, thank you.